was measuring solar radiation, basically the intensity of the sun with regard to certain chemical reactions. Basically, other people were going to study what chemistry at night would do. So during these scheduled night flights, originally I wasn't planning on measuring anything because there's no sunlight. But then a colleague of mine said, and also the pilots actually of the airplane were surprised how bright it was at night during the first night flight. So I modified the instrument a little bit to be able to have a higher sensitivity and measure these city lights, and then just kind of put a number on what they could do for a nighttime chemistry. After the first time I had the instrument on the higher sensitivity, I was surprised how bright those city lights were, and I was able to actually convert it into some chemistry value basically that would tell me if there would be an impact on compounds, on chemicals present at night in the air. We knew ahead of time that there was one target that would be the only plausible molecule that would actually be affected by the city lights, and that's the nitrate radical. The function of the nitrate radical is basically to react with other compounds at night, and many of those are pollutants, so by it reacting with them, it removes many of them from the atmosphere. Because it is so sensitive to light, during the day it's negligible in its concentrations, and at night then it builds up because of the lack of light there. So then the thought was, well, do the city lights kind of bite off a little bit of that concentration that builds up during the night? And the answer is yes, to a small but not insignificant degree. It is good to hear from these policymakers, and it could potentially be important for them to be aware of this effect.